When installing a 15 kilowatt natural gas generator and extending the pre-wired transfer switch wiring, several factors need consideration, including wire sizing, splicing methods, conduit length, and voltage drop. The transfer switch is pre-wired with number 6 American wire gauge for the hot conductors and number 8 American wire gauge for the neutral, all within a 30-foot length of flexible metal conduit. If the distance to the generator is about 65 to 70 feet, and the generator has a 65 amp 220 volts breaker, splicing in additional length is an option, but it requires careful evaluation. Firstly, regarding splicing, using a junction box to extend the existing number 6 American wire gauge wire is acceptable, provided the connection is made with appropriate connectors listed for the purpose and the junction box is accessible. Always refer to local electrical codes and regulations, but generally, splicing within a junction box is a standard practice for extending circuits. Secondly, the question of whether 70 feet is too long for running a 65 amp 220 volts circuit in conduit depends on several factors. According to the National Electrical Code, or NEC, Chapter 9, Table 9 provides the allowable ampacities for conductors and conduit based on conductor type, temperature rating, and the number of conductors in the raceway. For a 65 amp circuit, number 6 American wire gauge wire is generally acceptable, especially if using conductors with a 90 degrees Celsius insulation rating. However, the NEC also addresses voltage drop. Voltage drop is the decrease in voltage along the length of a conductor due to its impedance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even fail. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, the following formula can be used. Voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current resistance for the conductor material, I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. For copper conductors, K is approximately 12.9 ohm circular mils per foot. In the scenario described, with a 240 volts single-phase system, a 70-foot one-way run, and a 65 amp load, the voltage drop can be calculated as follows. The circular mils for number 6 American wire gauge wire is 26,240. Voltage drop equals 2 times 12.9 times 65 times 70 divided by 26,240, which equals approximately 4.4 volts. The percentage voltage drop is calculated as voltage drop percentage equals voltage drop divided by source voltage times 100. Voltage drop percentage equals 4.4 divided by 240 times 100, which equals approximately 1.8%. A voltage drop of 1.8% is well within the NEC recommended limits, indicating that number 6 American wire gauge wire is adequate for the 70-foot run. Thirdly, consider the conductor temperature and insulation rating. The question mentions a conductor temperature of 69 degrees Celsius. Using wire with a 90 degrees Celsius insulation rating is appropriate, as it provides a safety margin and ensures the wire is not operating beyond its rated temperature. When selecting conductors, always refer to NEC Table 310.15b16, which provides the allowable ampacities for conductors based on insulation type and ambient temperature. Additionally, directing factors may need to be applied if multiple conductors are bundled together in a conduit or if the ambient temperature is high. For example, NEC Table 310.15b3 provides adjustment factors for ambient temperatures other than 30 degrees Celsius. In summary, to ensure the installation is compliant and safe, consider these points. 1. Splicing the number 6 American wire gauge wire in a junction box is acceptable, provided the connections are properly made and the junction box is accessible. 2. A 70-foot conduit run for a 65 amp 220 volts circuit using number 6 American wire gauge wire is generally acceptable, as long as the voltage drop is within acceptable limits. 3. Using 90 degrees Celsius rated wire is appropriate for the anticipated conductor temperature. 4. Verify that all components are listed and labeled for their intended use. 5. Ensure compliance with all applicable codes and regulations, including local amendments. 6. Consult with a qualified electrician or electrical engineer if you have any doubts or concerns about the installation. 7. Always disconnect power to the circuit before working on any electrical components. 8. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses, when working with electricity. 9. Double-check all connections to ensure they are tight and secure. 10. Label all wiring and components clearly to facilitate future maintenance and troubleshooting. By carefully considering these factors, the installation of the 15 kilowatt natural gas generator can be completed safely and in compliance with applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to consult with a qualified professional if you are not comfortable performing the work yourself. Furthermore, it is important to understand the difference between ampacity and voltage drop. Ampacity is the current carrying capacity of a conductor, while voltage drop is the reduction in voltage along the length of a conductor. While number 6 American wire gauge wire may have sufficient ampacity for 65 amp circuit, it is also important to ensure that the voltage drop is within acceptable limits. If the voltage drop is too high, it may be necessary to use a larger conductor size or reduce the length of the run. In addition to the factors already discussed, there are a few other considerations that may be relevant to the installation of the 15 kilowatt natural gas generator. Firstly, grounding. Proper grounding is essential for electrical safety. The generator, transfer switch, and all associated equipment must be properly grounded in accordance with the NEC. This typically involves connecting a grounding electrode conductor from the generator to a grounding electrode, such as a ground rod or water pipe. Secondly, overcurrent protection. The generator must be protected by an overcurrent protective device, such as a circuit breaker or fuse. The size of the overcurrent protective device should be based on the ampacity of the generator's output conductors. In the case of a 65 amp generator, a 65 amp circuit breaker would be appropriate. Thirdly, surge protection. Surge protection can help to protect the generator and connected equipment from damage caused by voltage surges. A surge protective device, or SPD, should be installed at the generator and at the transfer switch. Fourthly, ventilation. The generator must be properly ventilated to prevent overheating. The manufacturer's instructions should be consulted for specific ventilation requirement. Fifthly, fuel supply. The natural gas supply to the generator must be properly sized and installed in accordance with applicable codes and regulations. A qualified gas fitter should be consulted for this work. Sixthly, permits and inspections. Depending on the location, permits may be required for the installation of the generator. It is important to check with the local building department to determine what permits are required and to schedule any necessary inspections. Seventhly, maintenance. The generator should be regularly maintained in accordance with the manufacturer's instructions. This includes changing the oil, checking the spark plugs, and inspecting the wiring and connections. Eighthly, load calculations. It is important to perform a load calculation to ensure that the generator is properly sized for the loads it will be serving. This involves adding up the wattage of all the appliances and equipment that will be powered by the generator and comparing that total to the generator's output capacity. Ninthly, transfer switch operation. The transfer switch should be tested regularly to ensure that it is operating properly. This involves simulating a power outage and verifying that the transfer switch automatically switches the loads to the generator. 10thly, emergency plan. An emergency plan should be developed in case of a power outage. This plan should include instructions on how to safely operate the generator and transfer switch, as well as contact information for emergency services. By taking these additional considerations into account, the installation of the 15 kilowatt natural gas generator can be completed safely, reliably, and in compliance with all applicable codes and regulations. Always consult with qualified professionals for any electrical or gas work.